Okay, so I'm going to explain to you what a D-flip-flop is. It's really, really simple, not that difficult to understand. Once you understand, this is pretty much like the easiest flip-flop to understand. So to understand first what a flip-flop is, basically a flip-flop is storage, right? Storage means that we can save bits. So normally a flip-flop only saves one bit. Saves 1 bit normally. Now obviously there's other type of flip-flops, some bit more complicated ones, but the general rule is flip-flop just saves 1 bit. And yeah, like when you see memory and stuff, those have flip-flops. Nowadays, technology has advanced so much, and maybe we don't use flip-flops anymore. I'm not really sure. I'm still learning that, but just to understand that's like the basic, kind of gist of it. So now, given this, we can start off by explaining what a D flip-flop is. D means delay. It stands for delay flip-flop. And normally flip-flops have ands and stuff, but basically they're always going to come as a little black, well, not little black, but like little squares, so to say. And this here is delay. This one is here clock, but we always write here CLK. We write like that, and then we, yeah, whatever. And then here is gonna be that, and then here is gonna be that. Oops, this line is crooked a bit. And this one is gonna be Q, and then not Q. So we have this thing, right? What does this actually mean? Well, this is pretty simple. So to explain this, I'm gonna make first a couple, lines so you guys can understand. Let me just do this. Don't worry, I'll explain it soon. Right? And then we have the D, and the D. Maybe do something as, let's do first of all like something as such. It's a bit tedious writing all of these guys. And then we can just keep going. And then we have our Q, which is the actual important thing. So let's say, what does a clock do? What is a clock, right? A clock is basically just like your computer. Let's say if I turn on my computer will start running, right? And if I write hello on my keyboard, I will type it into the screen, right? However, what happens if I don't turn on my computer? If it's off and I write my keyboard, nothing is going to happen, right? This is like an analogy to understand a bit better what the clock does in this case. The clock in this case is turning on the flip-flop, basically. So whenever it's down, it means the flip-flop is not taking any information whatsoever, and it's going to be off. However, if it's on, in this case, just like so, it means it will start taking information in this case. And now we can see here the delays. The delays basically just tells you what it will happen. So let's see. First of all, we have our clock. In the first 2 seconds, let's say these are seconds, 1 and 2. The first 2 seconds, not like the flip-flop is off. And while our value here is 1, in this case, let me just change the pencil real quick, if I can. Our value here is 1 because it's in the upper limit. So 1. However, our Q is still going to be 0, right? Why? Because, well, yeah, it's just simply, the clock is off, meaning the flip-flop cannot really save the value of 1 there. However, we can see that it goes up and then down, and within this constraints, stuff happens. And we can actually start writing stuff that happens within our flip-flop. So in this case, we can see that for the first second, it's down here. It's down on our D, meaning in our Q, it's still going to be down. However, here, it goes up, right? The edge goes up. It means this will go up, right? This will go down. Oops. And then we'll go down again because this value is also over here. And then it will go up again because it's still within the constraints of the flip-flop right here, as you guys can see. And then we'll go on up until we get to the clock, right? The clock turns on again, and we get that our value goes down. So it'll go down this time, and then it will stay like so. So this is basically how it works. Again, the clock, whenever we change our Q, our clock has to be on. So basically, if you want to look at it in a more simple way, this is constrained by this, right? This is constrained like this. And it's also constrained by this. So that's pretty much how it goes. This is pretty much a concept of what our D flip-flop does. And the next video, we're going to be looking at our T flip-flop or RS. I think we're going to do the RS one first. So yeah.